In this video, we'll be going over one last conversion, this time moles to individual particles, and our individual particles in this case will be atoms again. So starting out with the value 22 moles, and we'd like to convert this to atoms. We're going to set this up using dimensional analysis again, and so generally our first step is just to put this over 1 so that we are dealing with just fractions here. And we're going to be multiplying this by some conversion factor. We can start off by figuring out where our units will go. That's generally a good approach for dimensional analysis. So looking at the moles on top, we can see that our conversion factor should have moles on bottom in order to cancel, meaning that atoms, our individual particles, will go on the top. Next, we need to think about where the numbers will go in this case. Again, there are 6.02 times 10 to the 23 individual pieces in 1 mole of whatever we're dealing with. Since our individual pieces are the atoms here, the 6.02 times 10 to the 23rd will go up there with the atoms. That will leave 1 mole at the bottom because 6.02 times 10 to the 23rd atoms is the same as 1 mole of atoms. Now that we have this set up, and we again see that based on our reasoning, we did get it so that the moles will cancel, leaving us with atoms like we want. We should be able to solve, and in this case we will come up with an answer that when rounded to proper number of sig figs will be about 1.3 times 10 to the 25th. Should be 1.3. And our units here will be atoms, the remaining part. The number of sig figs came from the fact that our non-exact values were the 22 and the 6.02 times 10 to the 23rd. 22 has 2 significant figures, the 6.02 has 3 significant figures, so we need to go with the lower number, which is 22. And so our answer has 2 sig figs as shown. To go through calculators with this again, in this case, the issue of order of operations will not really come up. So no matter how you enter this, as long as you enter something that is reasonable, you should end up with something that is going to be correct. The reason for this is that we're not dividing by something in scientific notation, and so the issue that we saw in the atoms to moles version is not going to come up here. Still, we can think about what would probably be the best way to enter it. And I would generally enter this in the calculator as 22 times my 6.02. Then I use my EE button for scientific notation, which shows up as a little capital E, 23, and then equals would give us the answer. You could also show this writing out the scientific notation in more explicit form as 22 times 6.02 times 10, and then your exponent 23 equals. And like I said, because we don't have any issues due to that order of operations messing things up, this will give you the correct answer. However, it would probably be good practice just to get in the habit of using parentheses, because if you do end up dividing by a value in scientific notation, it will be important to show it as such. And so you could put parentheses around this value in scientific notation just to get used to being in that habit. All of these should lead you to the same answer, which is what was shown up at the top at 1.3 times 10 to the 25 atoms. And that should complete this problem. Now that we've gone through examples, hopefully you'll get a chance to try this out with the homework assigned over the weekend, and good luck with these problems.